Hello, Calc students. Today we'll be going over Newton's method. So Newton's method is an iterative process for finding approximate solutions to the equations of the form of f of x equals 0, as you can see here. And instead of guessing the solution, we use a systematic approach to find an initial guess until we get closer and closer to the root, which is the solution. The idea is to use the tangent line to the function at a point to estimate the root. The formula for Newton's method is x sub n plus 1 equals x sub n minus f of x sub n over f prime of x sub n. So you might be wondering, this looks a little bit weird. So what does each part mean? So x of n is the current approximation, and f of x of n, which is just the function value at x of n, and f prime of x of n is just the derivative of the function at x of n. And then x of n plus 1, that's sort of like, you could think of it as the next guess, if you would call it that, for example. So it's step-by-step process, okay? So you begin with the initial guess, okay? This could typically you're given like a domain, like for example like 2 to 3 or something like that, and you'd choose, let's say, 2.5 or something like that. But it really depends. But that's your first step, finding out like what's your initial guess depending on the domain. And then you want to figure out the different parts, such as f of x sub n and f prime of x sub n, and you can use the formula, and then you could find your next guess right here, and you can keep doing this iteration by using this for this, and then you can keep doing this until you get closer and closer to your root. And why does it work? Well, it relies on the tangent line at x of n. The root of the tangent line serves as a better approximation for the root of the function, and if you keep repeating this, it refines the guess. For example, let's say that we're given a problem. Example: find the root of x squared minus 2 equals 0. You could just add 2 to both sides and then find it that way and find the answer is root 2, but plus or minus root 2. But you could also just start with an initial guess. Let's pick your initial guess as x naught, for example, and let's say it's 1.5. Now let's go through this. So the derivative of f prime of x in this case would be equal to 2x. And if we do the process, you would get x sub 2 is equal to x sub 1 minus, sorry about that, no, x sub 1 is equal to x sub 0 minus f of x sub 0 over f prime of x sub 0. So then if you plug in these values using this, you would get that it's equal to 1.5 minus 0.25, because f of 1.5 is equal to 0.25. And sorry about that. This should actually be just this. There's no equal 0. It's just the root. And try to find like when it equals 0. So yeah, sorry about that. And it's over 3, and this is equal to 1.4167. This is not this is close to the answer, but you can use this again one more time. So again, you would repeat this process. So you would get that x sub 2 is equal to this number, which would be 1.4167. Then you would do f of this number. So that would be 0.0069 over 2.8334. And this 2.8334 is f prime of 1.4167. So you just plug in this number into that to get this number, if you were wondering. And then once you do that, you set it equal, and then you get the answer as 1.4142. So this is sort of the roots of this function, you could think of it as. And this is really, really close to this number right here. So you know that you're on the right track, and that this is essentially the end of this video. So this really shows that like Newton's method is a very, very simple, but it's also very useful technique in calculus to find zeros of a function. And it's really, really powerful for finding roots quickly and accurately, especially when solving equation by hand isn't practical. Just make sure that your like initial guess is like hopefully close enough to the root, and be cautious of cases where f prime of x sub n equals 0, because this would make the formula invalid, because you can't have denominator in the 0, as it would lead to undefined. And yeah, that's pretty much it for this video. And if you like more content, please subscribe and reach out. And one more thing, if you would like to try this other problem, I'll have it right here. You can post your answer. Let's try this one. X to the fourth minus 5. I want you to find the roots for this one, using Newton's method. So yeah, that's it for this video, and have a great day.